and some scientists were looking at some chemistry that we understand in the upper atmosphere of Venus. Basically, CO2 is being Venus is mostly CO2 in the atmosphere, is being destroyed by ultraviolet light, so you would expect a lot of oxygen as a byproduct of that. But there's almost no oxygen or oxygen compounds observed in the or pure oxygen compounds observed in the highest atmosphere of Venus, and that was a mystery what was happening to them. Some other scientists said, well, we've done these experiments, and we found that chlorine has this catalytic effect of destroying ozone and other oxygen compounds, and we think that's what's happening on Venus because there's a little bit of chlorine up there. And then some other scientists read their paper and they said, oh, that's interesting. Chlorine can destroy ozone. Well, what about that chlorine that we're starting to put up in Earth's stratosphere from all these CFCs, these refrigerants that are breaking down up there? And then said, uh-oh, wait a minute. That's not good. And sort of sounded the alarm. So there was a direct chain of inference from these observations of Venus to the realization that with these chemicals that had been introduced because they were safe, environmentally safe and non-toxic, these CFCs, and therefore an improvement over the dangerous and stinky and toxic refrigerants like ammonia and things like that we had been using before them. And they were non-toxic and safe in the troposphere down here at the surface of the Earth where we live. But then we started using them enough and they started leaking up into the stratosphere where there's enough ultraviolet light so that that radiation started nicking off chlorine atoms, the chlorine in the CFCs, and those naked chlorine atoms started destroying the ozone. So it's a classic example of unintended consequences. Who would have thought, you could do all these experiments and say this stuff is perfectly safe, it's not toxic. But who would have thought to, think about what happens when it, it's up at, in the upper atmosphere. So it's also, though, an example of the next kind of change I want to describe, because what happened here is that scientists sounded the alarm. There was an international global discussion of this, what to do about it. There was a big argument, a lot of disagreement. There were people that denied the science. There were the companies that manufactured this stuff that stood to lose if they were banned, hired experts to do fake science and say that it was just a hoax and cause a lot of confusion. A lot of the same stuff that's happening now with global warming and oil companies and so forth. But in this case, the truth won out, and global agreements were made. Treaties were signed, the Montreal Protocol for the reduction of ozone-harming substances, and the companies phased out making these chemicals and figured out how to profit from making the replacement chemicals, which now are used for refrigerants, which don't have this dangerous side effect. So this ozone situation is also an example of what I call planetary changes of the fourth kind, intentional planetary changes. And it at least is an existence proof. It shows that it's possible that we are capable of this other mode of interacting with our planet, which I think is going to be key in our effort to navigate the next couple of centuries. Now, other examples of this, these planetary changes of the fourth kind, inadvertent changes, obviously the most pressing one now is dealing with our slowly building carbon dioxide climate emergency. And there's some good news and bad news, of course, on that front. The solar and wind are getting cheaper, and in this country, the last couple of years, our carbon dioxide emissions have actually leveled out. Globally, they're still rising. We have a lot of work to do. It's not at all obvious that that we're going to do this the easy way, although we are going to do it. There's going to be a post-fossil fuel age. It's just a question of how gracefully and with what kind of damage we get there. So that's the most urgent of these changes of the fourth kind, is getting a handle on this. But it doesn't stop there. One of the points I make in the book is that once we gain this ability to make these intentional kinds of changes, we have the possibility, and therefore I would argue the obligation, to in some ways take a more active role in managing our planet. And there are certain threats that we can anticipate and mitigate, not just threats to ourselves and our own survival and our own civilization, but threats to the rest of life as well. And a couple of examples of this are the threat of asteroid impacts. You know, the dinosaurs didn't have a space program, we do, and therefore there are a lot of objects out there that threaten us. In fact, this is where I'm going to show you that the simulation that I got from, let's see if I have it queued up here. Yeah, this is cool. I also got this from the Cal Academy. These are actually the real orbits of all the known Earth-crossing asteroids that we've identified so far, obviously sped up. But so that's Mercury, Venus, Earth, Mars, Jupiter, Saturn, and these are all objects that we know of out there that are on orbits that can eventually intersect Earth. And of course there are others that we haven't discovered yet. So this is all by way of saying, you know, if we wait long enough, left to its own devices, Earth's biosphere would suffer another impact like the one that did in the dinosaurs, or worse, one that could end all life. But we also know how to deal with this now. We're finding these objects, and there are quite reasonable ideas of how we could build a system to go out and divert one. You don't have to blow it up or destroy it, you just have to give it a little push and change its orbit, actually very slightly. And most of these we would have several years, you know, more than several years, decades even, of warning, and it wouldn't be that hard to mitigate this. So that's a role, I think, once we get better at this with these planetary changes of the fourth kind, we can actually play a constructive role and help to protect life from things that would otherwise cause future life to have a very bad day, like the day that object hit and did in the dinosaurs. I'm going to read just a very short passage on this topic, actually. See if I can find it. Yeah. And I give some other examples. One of the other things I talk about is climate change is something that we think of as just a human-caused problem, because right now it is. But in the long run, we have this illusion that if you leave climate, if we just left the climate alone, Earth would be fine and be this paradise, and all life would be happy. But of course that is an illusion, because we've come along at this really weird time in Earth history. This 10,000 years during which our to what extent we have one, civilization has sprung up, has been a time of very stable and warm climate. And that's very unusual. It's an aberration in Earth history, and it won't last. Left to its own devices, Earth would go through another ice age, which is something that we do not want to experience. It would be much worse than any climate change we're facing now. It would certainly be the end of our civilization, and it would take a lot of other species with it. So the good news is that this is not a problem for at least 10,000 years, probably more like 50,000 years. So we have much more immediate concerns. But once we realize that without first being aware of it, we've created for ourselves and sort of inherited this role, whether we like it or not, of being planet shapers, and we get over our more immediate climate vandalism, then I think in the long run we will want to learn enough about our planet and about ourselves to be able to play this more constructive role, and there doesn't have to be another ice age. It's sort of daunting to think of ourselves in this role of sort of managing the global climate, but I actually think that if you really think it through, then that we sort of have no choice but to realize we are a planet-altering force and try to actually become better at it. So I'm going to read a little section here about space defense.